Hello and welcome to the JavaScript and Edmonton JavaScript Ruby Meetup. So we have a speaker tonight, and I'll get the slides going in just one sec. Okay. All right. So welcome to the JavaScript and Ruby Meetup. This is for May 2022. A lot of twos in there. And we will be uploading this video to YouTube. The agenda for tonight, we're going to talk about code of conduct. We're going to talk about news. We're going to talk about talks, and then we'll socialize a little bit at the remote tables. All right. So we've got a code of conduct, and it basically can be summarized as be tolerant, be nice, be awesome. You can go read it in the general chat if you feel like it. I've given you a link there, and we basically abide by the DevEdmonton code of conduct. Yeah, so be kind, be patient, and be awesome. All right. So if you're interested in talking after the talk with people throughout the rest of the month, we have on the DevEdmonton Slack, we've got the Meetup, the Meetup Ruby and the Meetup JavaScript. And those you can get to if you just go to devedmonton.com and you go and click on the Slack. You can join our Slack. There's a lot of chat in there. There's also dev help and some other channels, as well as more meetups. So if you're interested in programming meetups, definitely join our Slack. Okay, this video will be uploaded to YouTube. So if you show up on the screen, you come to the presenter table, the stage, you'll be on YouTube. If not, you're not really going to get mentioned. We might name your name if you ask a question directly, but beyond that, if you're not presenting, you're probably not on YouTube. If you are presenting, you will be on YouTube. Maybe. Now, we are looking for more organizers. We are looking for additional organizers for the Edmonton JavaScript Ruby Meetup. We're hoping to get at least 2 more. And if you're interested in helping run the show, which is basically procuring talks, setting up the AV, setting up Remo, stuff like that, finding speakers, helping people out in the channel, and then maybe even transitioning, we'll eventually probably transition to in person, so we'll need help there. If you're interested in any aspect of the organization, we'd love to have you aboard, even if it's just doing a little bit like, just setting up slides, setting up, finding people who want to hear about us, finding people who want to, finding more audience, that kind of stuff. So just pretty minor stuff, maybe some promotion stuff too. We got all these different aspects. You don't have to do everything, but we want more people to join in, and a successful community usually has a successful organizational community. So please consider joining our org group to help organize the JavaScript Ruby Meetup. Okay, if you are interested, on the Slack, contact Ian, Abram, or Andy. Okay, so there's talk in chat. I could help with finding more people. That would be excellent. Even just directing people to DevEdmonton, our channel, our meetup, that'd be cool. Definitely appreciated. Okay, so we'll start off with the Ruby news. There's lots of new versions of Ruby, or Rails, sorry. We got Rails 7.7024, 6151, 6048, and 5271. So lots of different versions on different branches of Ruby, or Rails, sorry. Ruby itself, there's new versions, and they're basically finally done with 2.6. So 2.6.10 is the final Ruby 2, okay? The Ruby 2 is done. This is kind of like the Python 2.7 moment, Then we got new versions of Ruby, and there's this interesting thing, the Opal, a Ruby to JavaScript transpiler, because, well, maybe you don't want to write JavaScript, right? But you could write Ruby, and it could write JavaScript, right? So you could write Ruby and just have it run in the browser without a lot of worries, other than maybe some of the C libraries. Also, there's a new version of Ruby Gems. Yeah. In JavaScript news, new versions of React came out, Node.js 18 came out, and the LTS version has a backport of the Fetch API. So you can do your HTTP requests using Fetch, because Fetch is way better than some of the other alternatives. A cool thing is faker.js. It's basically an API for making fake stuff. So if you need like a fake animal, like a bird, it can make a bird. If you need fake finance information, you could get accounts and names, rando names, names of accounts, all that kind of stuff. If you just need to, write a web page, they got your Lipsum Aurum kind of stuff. Cool. Phone numbers, music. Oh, okay, genres. That's cool. Yeah, so fun stuff. So you need fake data. You need to demo. Nothing's worse than demoing with test. Why not demo with actual data, right? So faker.js. New version of Electron. And then Jasmine, because you should do testing. You get feedback when you do testing. I'm not sure what's in the new TypeScript 4.7 beta, but that's interesting. And new version of Ember. Cool. All right. So we are part of the DevEdmonton Society. DevEdmonton Society helps organize meetups and organize developers in Edmonton. Essentially, it was started as a mechanism to basically have meetups have bank accounts, but it has since grown and blossomed through there with interactions with industry and Tech Edmonton and all sorts of different bodies doing all sorts of different things. So I recommend you go check out DevEdmonton.com. And DevEdmonton.com has its own specific meetings, which are basically to help run the show there. I'm also a member or a board member of DevEdmonton.com. So definitely worth checking out. Helps organize developers in Edmonton, and it's developer centric. We've got a meeting on May 11th next week at 8 p.m. Join the channel. And we've also got the Dev Edmonton survey, which I can't copy and paste, but maybe Andy can help me there. But if you're interested, join the Dev Edmonton Society channel on our Slack, on the Dev Edmonton Slack, and we're good to go. I really do recommend joining the Dev Edmonton Slack because it's got lots of great stuff. Lots of great people. Okay, our next meetup, we're going to meet June 2nd, 2022. A lot of twos in there as well. So be prepared. It'll probably be online. Not sure who's speaking, but we're always looking for speakers. If you're into it, definitely give us a call. So exchange.js/talks or YegRB, get involved, either one. Those can help. Also, there is a Google form in the JavaScript channel, at least, and it lets you sign up for JavaScript talks if you want to give a talk. Now, speaking isn't that hard, and you don't have to talk for very long. Lots of times we just want to hear about a cool project you worked on. So you got 5 minutes, you can give us a talk. You want to talk about an operator in JavaScript or Ruby? Sure, have 10 minutes, do whatever you want. You want to talk about a new library you learned? That's great. Or even better, you want to learn a new library? There's no better way to learn a new library than being forced to give a talk on it. Then you really learn the library. Okay. So it's almost time for the main attraction. You want to demo or present, give us a call. Okay, so if you got questions, ask them in the Remo chat, and we'll help collect them and collate them for the speakers. Okay, so first up for tonight is Mark Bennett, going to talk to us about his lessons building with XState. So we'll go to participants, promote Mark to the table. All right, so Mark can join the table at will.
Okay, I remembered this time that I have to turn my camera on before I see myself. All right, I'm just going to share one of my tabs with you. Give me a moment here. Okay, so where is it? Okay, can everybody see my screen there?
Yeah, I can see your screen.
Okay, perfect. So I'm just going to put Remo on one side. So I can theoretically see the questions and chat on the other. If you have questions, just so that they stand out a little bit more, if you look on the right, there's like a chat and a QA feature. If you could use the Q&A one for questions, and I'll try to monitor the chat, but they'll pop out at me if you use the Q&A one.
Hey, Mark, if you go to present and you go to presenter view, it will make your presentation full screen for the window.
Oh, nice. Okay.
So you can have your window set up however you have already got it set up.
Perfect. Here, I will switch that one moment.
All right.
Okay, let's try that. All right, there we go. Does that look better?
Yep, great. Thank you, Mark.
Yeah, no problem. I can still see my presenter slides. Perfect. Okay. So I'm going to keep this pretty quick. I have 28 slides, it says, so I'm going to try to go through them fairly fast. And I will pause time to time for questions and stuff like that. Oh, let's go. First of all, Mark Bennett from Burma Studios. I'm a JavaScript Ruby developer. I've been for quite a while. I recently started using XState to rewrite a critical part of a client's app using something called the Finite state machine. And this is kind of some reflections on how that went. So first up, a quick definition. Quick definition for people. A finite state machine, according to Wikipedia, is an abstract machine that can be in exactly one of a finite number of states at any given time. The FSM, finite state machine, can change from one state to another in response to some inputs. The change from one state to another is called a transition. So we're going to be talking a lot about states in this talk. Basically, the important thing to remember is that these machines are a way of kind of modeling the state in your application. They have different states that they kind of transition from. We'll see some examples of those. And as they move from one state to another, we call that a transition. So that's really all you have to know for the purposes of this talk. So XState. XState is a JavaScript library for implementing finite state machines. Each of the machines has many states, and the states have transitions. These transitions have something called guards, and what they do is they prevent a transition from happening unless certain conditions are met. So basically, they're just an expression that if it returns true, the transition happens, and if it's false, it doesn't. So, and you can have groups of them to kind of figure out as an event happens where you go from one state to the next. When you enter or exit a state or make a transition, you can trigger actions, and actions are what cause side effects outside of your machine, and everything coming into it comes in through sending messages and triggering events. Actions are run synchronously. That's important too, because there's also an asynchronous way of running things using services. So basically, services have to communicate with a machine by sending and receiving events. And depending on the state, the event could trigger a change and then transition to another state, or it might just get ignored if the machine doesn't care about it. In the case of XState, machines that I've used are typically promises, but they can be all sorts of things like observables. They can just be functions that use a callback, or they can actually be one machine embedded inside another as something called an actor. So there's quite a few possibilities there. You can really kind of go down the rabbit hole of using those. I have found promises are a bit simpler, so I've mostly stuck to those. But yeah, you can have some really neat things with one machine passing messages to another and, you know, running in a worker thread or something like that. So there's lots of cool ways you can use it to break down your app. So this is just a quick example of what one of these looks like. You'll see a lot of these diagrams. So here, this is a machine. It has a first state. And when it comes in on entry, we say it runs a load action, which can do whatever it's going to do. And then it also invokes a loader service. And so that would be maybe a promise that would go and load some data from somewhere. And then when it's done, it would resolve. And here it would go and trigger the receive action or the receive event. And if it's valid, so if this guard passes, it goes to the second state. So here we've got a machine, we've got two states, we have an action, a service, and a transition here on an event. So you can see in the source code, it looks a bit like this. So the ID is the basic machine. The initial state is described there. There's two states that are in it. The first state here, second state there. And then you can see on entry, it triggers an action. So whenever you see entry, that's an action. And then it invokes a service. So you'll see you enter and exit. Those are actions. And invoke is when you trigger a service. And that only ever happens when you come into a state. For each state, you can have this on property, and it basically says on a different event, when you're in this state, this is what you should do. So any event that comes in that isn't listed in there will just get ignored. So in this case, when we're in the first state, the only event that will trigger reaction is a receive event. And it has this condition, this guard, that will check before transitioning to the second one. So does that make sense? So the other thing that you'll see when you're building stuff is that you've got two kinds of objects that you're really using in your applications. Excuse me. One is a state machine. And so state machines are stateless. And what that means is that whenever you're working with them, you have to pass in the current state. And then the machine will interpret that state along with any event that you pass in and return a new state based on it. So it's sort of like what you might be used to with something like Redux or reducers, things like that. And so you're often just going and creating a new state and then, maybe saving that in your app somewhere or something like that. So you will see a lot of the time that, people maybe coming from Redux will use these machines, but you can also go and have something that's more persistent, where it has state. It's called an interpreter. And basically the only difference is that you create an interpreter from a machine, and you can go and wire things up to it if you need to. Then you start it, and rather than passing in a functional event here, you just send it messages, and it would then respond to those events that way. So interpreters have state, machines on their own don't. Okay. So the good, right away, one of the cool things that I found really useful when I was starting off is XState. Someone has built this really handy little editor. So you can see this was the machine I used in my talk today. And the cool thing was that you can come in, you can click on it to add new states. You can add things that happen when you go in a state, add transitions, all sorts of stuff like that. And, it's very kind of what you see is what you get. And you can build fairly quickly some fairly complicated machines. And the nice thing is that it's all validated and stuff like that. So you don't have to worry about fussing with JSON and things. And it also has a cool little option to simulate it. So later on, you can come in and you can either manually enter events to see what happens if you're passing data in with them and stuff like that. Or you can also, for example, here, if I was in first state and I clicked on receive, it would go and just trigger that receive event and send you to the second. So it's pretty slick when you're just kind of figuring things out and trying to get a sense for how stuff might work. So that was one of the good things. The other one too is that I just found in general, it was very reliable and stable. Once it was written and tested, I felt really confident that the machine was going to be more resilient than the code that was there before, because you're kind of thinking in these states and transitions. And if you don't have, one explicitly set, a lot of the activity will just get ignored. Then you have to kind of think through each step of your app. And in doing that, I found a lot of weird little edge cases and stuff like that I honestly hadn't considered in the more kind of just clenched together code that this was replacing. So yeah, overall, I felt like it made my code more reliable and stable, which is a big plus. The other thing too is that XState in particular had a lot of useful utility functions that were built into it, and you could use, so for those actions and things like that, they had things where you could go and just, when you're triggering like an entry or an exit or an action on a transition, you could send an event, you could go and log something, you can raise, which I found a weird name. So there's escalate is for doing errors, and raise is for actually going and it kind of like send will immediately send an event to your machine and it'll handle it. Raise kind of puts it on a queue, and then the next tick, it'll go and get processed then. So there's just a little bit of a delay there kind of, and you can fill up a buffer almost of events by doing raise. Whereas with send, it's you send it and then it's immediately processed and that's it. You can't do anything else. So The other thing too was that assign is a really useful one because it lets you go and update the state of the machine based on the current state, and it's almost like doing a reducer there. So that's often what you end up doing when you're writing kind of custom functions anyway. So it kind of offers a shortcut to do that, and it was a nice way it would merge the current state with whatever you pass in. So especially once you have a big state, it was a nice way to do that quickly. I will say one of the things that was annoying is there was a page that lists all of these actions, and it was useful, had examples and stuff like that, but it didn't list this assign one. The assign one is listed, or even refer to it. It was listed on a separate page talking about the context for your machine. And so for me, when I was first kind of going through the docs, I found these actions. I thought that was all of them. I didn't even know about assign until I found some other source code, even though it would have been very helpful to have. So that was kind of annoying with the documentation, and something I will come back to as a theme in this doc. The other thing that is really cool about XState is that it's got a really mature and solid ecosystem around it. So pretty much any of the front-end frameworks, React, Vue, Angular, they all have really solid XState implementations that integrate. The things like Visual Studio Code and most other editors have either official plugins or community ones that do stuff like you can kind of highlight the JSON for a machine and then pull up the visualizer right in your code. So that was nice. You could kind of see what was going on and even edit it in the browser, or in the editor, excuse me. And there was also browser debugging tools. The official one was kind of weird because it actually integrates with the Redux dev tools. But it kind of makes sense because the events are just like events that you would pass to your Redux reducer anyway. So it was a little kludgy, to be honest. I found most of the time I was just going and putting in log actions and using unit tests for making sure everything was working. But I did pull it up and it was helpful. And I think especially if you had a bigger application, you might use that more. So the other cool thing that I saw was you can create a machine that describes the state of your app and then use that to come up with a test plan for something like Jest or React test library. And together you can basically say, I'm going to cover all the different states of this UI and develop a test for each one of them. And so if the app ever changes, if there's like a new state or something, you can just add it, and then it will go and, if there's 50 states, it will go and generate a little test for each one of those to make sure that you can get to it and that it's working. So, and the cool thing was that the example I saw, they were using a state machine to come up with this kind of graph of different states for your app, but the actual front-end code wasn't using XState. They were just using it to test that the front-end code kind of followed the correct path through the different states. And so the example that they were using was actually a React shopping cart app. And so they had different states where, you were looking at a product, you were looking at your cart overview, you were making payment, and then it was done. And so you would go and basically in their state machine have a state for each one of those. And then you'd have a way for each state to check, like, am I in the overview state? And they were just doing things like looking for a header that said overview, but probably you'd want to make it more advanced than that. And then for every possible transition, you would have a way to trigger that. So, for example, if you were going and trying to buy something, they would have like a purchase button or something like that. So the cool thing was the front end app that they were testing wasn't using XState at all. The back end was, and they could go and very quickly come up with like a whole series of things where, you went and added something to your cart, then you went and looked at the overview and then came back to the product page and added another thing to your cart. And they could handle all the weird permutations of that, which would take forever to test by hand. But using this kind of graph, they could do it really quickly. So any questions about where we're at right now? I'll give people some seconds. Oh yeah, here we go. I see questions right there. So first question, did you use no UML state diagrams before using XState? So the answer to that question is yes and no. I did UML back in university. I have very lightly used it in application design and stuff like that. But honestly, I hadn't looked at it in years. Having said that, I think probably some of that did help in understanding XState, because XState does follow, I can't remember what the name of the spec is, but there's like a spec for designing these state charts. And XState is pretty rigorous about trying to follow that and kind of use what you'd see in other languages and stuff like that. So in terms of UML, I didn't specifically set out to use them, but you kind of just end up using something like it when you're using XState. Someone has asked, can I share a link for the editor? Yeah, so I will share that 1 second because it is slightly different than what I've got there. So can I switch to this tab? Okay, I'm probably going to mess up my presentation here, but whatever. I can bring it back. So this is Stately. They are the people that are like the main kind of sponsors of XState. So Visualizer is their older thing. This I actually find in some ways is easier to work with. Here, I'll just pull up an example. So you can see on the right, you actually have your source code. This is the JSON and stuff like that. And then you hit visualize and it makes a little graph where you can go and click on stuff like that. And then the editor is slightly different. It's new, it's in beta. And basically here you can come in and you can click on, say, like third state. And you can go and let's say add a transition to this state. Cool. Right. So then you can click simulate here, it starts it up, you trigger that event and you trigger that event. So it's a bit more advanced, but same kind of idea as the visualizer. So that's at stately.ai for both those. Okay. Back to the show. All right. The last question is, what motivated you to give XState a try on a real project? Okay, good question, Andrew. So honestly, I had seen that Kether had used it a while ago. I think he did a demo probably a few years ago now where he was using it for some UI stuff, where they were doing like 3D modeling and some more complicated interactions, and had said that they quite liked it and it worked well for them. I hadn't really had a good opportunity to use it, and we were working on, it's actually some authentication code with some complex parsing of tokens and stuff. So we needed to make sure that we were handling all those weird edge cases that can come up and that it was all secure. So we were auditing the code that was there and trying to test it. And as I was doing that, I thought, this would probably be a good candidate to replace with a state machine. So that is why we did. Okay, so if there's no more questions, I'm going to move on to talking about the bad, because there definitely was some bad. The first thing that came up, and to be completely fair, this is something that they point out many times in the documentation, especially on the actions page. There's probably 5 different places that mention this, but it was one of those things where you see it, you think you understand it, and then you start coding and realize you totally missed it. So basically what it says is that there's these actions available, but that you can't invoke them directly from a custom function. You have to go and basically use them in place of the function because they're an action creator, sort of like what you would see in something like Redux. So here, for example, is what I was originally writing. I was going and I had, this is kind of just a function that you can pass in if you're quickly prototyping. And I wanted it, in this case, to go and log something. And I would call this and I could see it hitting it and nothing would happen. And I couldn't figure out what was going on. It wasn't until I actually went back to the docs later and realized that you have to pass in log directly. And if you want to call multiple actions, then you just do this as an array. And even though log looks like it is going to be invoked basically when this is triggered, it actually returns a function which will be invoked later. So here, this wasn't called because this was actually returning a function, which I guess you can invoke then. But what you need to do is basically just not wrap it in your custom function and use it in place of it. And that's true for all of the different actions that you'll work with. So in the end, I don't know, I felt like it did actually make my code a little bit shorter once I got used to it, but that definitely caught me out, and it seems like it's probably caught out other people too. The other one that came up, and this one was a bit more annoying, was, like I said, we were processing some kind of tokens and things like that, handling some remote calls that we wanted to make sure we handled failure cases for. And so some of my promises, the code that was triggering them was throwing exceptions or raising errors, and it would just shut down the whole machine. So the interpreter would stop running and nothing would happen. And at the time, I found that quite annoying because I was looking for this to be a really reliable solution and stuff like that. What I've since found is that basically they always want you to return an object, and rather than throwing an exception or something like that. So, they made the example that if you're using a promise, instead of letting the code throw, it should reject, right? And return a rejected promise as a value. If you're using some of the other things, then it should go and, either trigger the callback that flags it as an error, or, the observable can close and things like that. So it was kind of weird. I found this was a little kind of unergonomic. I thought it would just wrap those errors for me and maybe call some error code when the promises were invoked. It doesn't, but once you get used to that, you can kind of live with it. And it wasn't the end of the world, but it did kind of throw me off again. Another thing too that was a bit confusing when I first started was there were these things called always transitions. And so they're a little weird and they can be really useful. Like for me, I have a state where I'm basically validating that everything looks normal and is working properly. And so I don't ever want it to stay in this validating state. It comes in, it goes, it tries to validate the state. If it can't do that, it goes into an error state. Otherwise, it goes either into authenticated or unauthenticated. And so because I didn't want it to remain in the state, I used this thing called an always transition. And basically what happens is whenever you go into the state, it immediately just starts a transition to another one. And it's called an always one because the attribute that you set on the JSON is called always. Anyway, that being said, when I was first trying to do this, I was testing in my tests and waiting for it to go into this validating state so that I could check that things were called and stuff like that. And the problem was it would never go into that state. And it took me a while to realize that that was not working because these states, whenever you have an always, are evaluated synchronously. And so perhaps internally XState does, change the state. But you won't see it, and none of the listeners or anything like that that monitor for state changes will be triggered until it's completely processed. So in the case of my validating, for example, it would go, and when authorization finished, it would go into the validating state and then immediately go into authenticated, and my listeners would never see that validating state getting called. So that was a little frustrating. I can see kind of why they did it, because you're never really meant to be in any of these states. And once you're used to it, it makes sense. But it's definitely something that kind of caught me off guard. And I would point out to anyone else trying it. And if you do need to do that, you can have something where instead you use an entry action and you send or raise to put another event into the queue so that you will have that momentary transition that you can test against. But usually you want to use always anyway so that it's never in that state. Okay, looks like no questions. The biggest thing that I really took away from it was the documentation. There's actually a fair amount of it, but it was surprisingly sparse in some places and then kind of almost too wordy in others. And so I found that even after reading it a couple times, I was still quite confused. And, I felt like there was a lot of theory kind of behind it and not enough practical examples. So, in overall, there was some categories. There was recipes, tutorials, guides. It wasn't really clear. And patterns. And it wasn't really clear, for example, which or what content would be in each one of those. Guides had 30 things in it, and then patterns only had one. And there was other times where, something that you think should be in one section would be in another, and they didn't seem to really link together very well. So that was another place that was a problem. In general, there was a kind of lack of code examples, I thought. And, the ones that were there were kind of the simple cases, the ones that wouldn't really mess you up anyway. And, you would be looking for the more advanced information sometimes, and there wouldn't be any example to go with that. So, and the final and the biggest kicker for me, especially once I started using it, is that the API docs are terrible. They have an integrated search, but the search will show you the methods on classes and stuff like that in the index. But if you actually start to filter by it, they just get filtered out. And so it was very hard to go and find specific methods. And also, like the formatting that they used, it was very hard to tell, for example, the start of a class and the methods defined on it. It was very hard to tell that apart from just another method name. The only difference was like a little C instead of an F, I think. And so you could just be scrolling through their docs and, you know, fly past a class that you were trying to find or something like that. So it wasn't a huge, I guess, complaint, because, you know, they at least had the docs, but like it wasn't well indexed and it was very hard visually to kind of search. So that was a big issue for me. And again, like just stuff like the assign action, even though it is used a lot, was not documented. So, and finally, the biggest thing that has messed me up and that I'm still fighting with, honestly, on this project is TypeScript, which is quite frustrating because I really like TypeScript. I have pretty much used it on all of my projects. I appreciate that I can catch bugs at, I don't know if you call it compile time, but before runtime. And a lot of the time, TypeScript has caught things and prevented bugs from shipping. So I really think that TypeScript is great, but TypeScript with XState is not great. It just seemed like whenever there's something that would go wrong, you would get, you know, a whole page of an error, and it would be very hard to tell exactly which properties weren't matching. There was lots of times when the documented fix was to use unknowns or any's and stuff, and you know, those are things we generally try to avoid on the projects I work on. So like looking at the time that I spent, I would probably say that at least half of my time in total was spent dealing with TypeScript warnings and stuff like that, rather than, you know, writing code or even writing tests. So supposedly the next version, they're working on making some of that a little bit clearer and a little bit simpler. But yeah, in general, I would say this is one of the few times where TypeScript really did actually slow me down quite a bit. And normally when I see a TypeScript error, I feel like it is preventing me from shipping a bug. Whereas in this case, it just seemed like the information wasn't getting through to TypeScript in a way that could help it infer, you know, what was kind of going on in that context, and kind of demonstrate that it wasn't actually a bug. There was lots of times when it would say, oh, this object is any, and so you can't use this property on it, or things like that. And you know, that information would have been declared elsewhere in the generics and stuff like that we were using, and it just wasn't making it through XState to the various places that we needed it. The last thing for that is testing. So we managed to get through the testing pretty well. I found a couple kind of third-party repos, a couple YouTube videos and stuff like that. But the testing section, for what XState seems like it's intended to address and to do, was pretty bare bones. And again, like this was one place where I felt like the examples were the very simple ones, and it would have been appreciated to have, you know, more complex examples of testing promises and services and stuff like that, especially asynchronous code. It turns out there are quite a few like resources in XState to do that. There was a function called wait for, which we found after I had spent a couple of days, you know, writing a bunch of utility functions to test our stuff. And then it turned out there was one in XState already. It just wasn't really documented or discussed or used in the examples. So that was frustrating, to be honest. So, you know, I think just in general, more kind of examples of people doing testing and more guides around testing more complex apps would be helpful. So wrapping up, my final thoughts, I would use XState again, to be honest. I feel like I have kind of, after about a month of using it, reached that point where I can be productive with it. And I kind of, when things go wrong, I know why they're going on, unless it's TypeScript. And I can usually get around them a bit more. If I were to use it again, I would probably look at doing a real app like this, but especially if it's my first time using state machines and, you know, dealing specifically with XState and some of the choices that they've made, I would double my estimate probably for time to get it done. But having said that, you know, I think if you had a complex app, it would save you time in the long run with debugging and stuff like that. So I guess my suggestion here is do use XState when you have complex state you're managing, when you have many events that can be interleaved together, and many actors potentially going through many interleaved processes at once. Being able to go and break it down into events and have that clear, log of what's happening in the app, and with the isolated state inside the state machines can be really helpful in discriminating and kind of breaking that down a bit. I also think it does help with eliminating bugs and improving correctness. So if that's important. The other one too is that I think it makes sense to use when you have isolated parts of your app that you can model as separate machines. Just being able to have that separation with the message passing back and forth is a nice abstraction I found, and it would kind of make it easier for me to work on one chunk of the code without worrying that it was going to be tightly coupled with another part, for example. There is a bit of setup though, in terms of getting it running, getting your head around it and stuff like that. So I would say I wouldn't use it when the setup is more complex than the rest of the application. So if you're building like a toggle or something like that, you probably don't need to use a state machine. But yeah, especially if you're doing complex UI stuff and things like that, it would definitely make sense to learn it. And I would say that compared to something like Redux, the idea of like a state machine as opposed to like a Redux store, for me, made a lot more sense. And it was easier to work with the state when I was passing messages back and forth between them, rather than having, a global set of reducers and dispatching reducer messages to different parts of it. So yeah, I would say for something like that, like if you're using Redux and looking for an alternative that it's a bit more event oriented, especially for UX stuff, it would be worth considering XState for sure. So I just wanted to quickly acknowledge the team that has put this together. I'm going to get his name wrong. I'm sorry. David Karishid, Matt Pakok, and there was quite a few other contributors that have done a lot of work. I think it's version 4 now. They're working on version 5, so it's been out for a while. Also, a big thank you to Kether Saturnis. He was the one that kind of pointed me in the direction of XState a few years ago, and it was fun to finally sit down and get a chance to use it with some of my code. So thank you. If you have any questions, you can find me. I'm at Mark Bennett pretty much everywhere. You can email me, mark@burmis.ca. Burmis.ca is my website. And you can also ping me on the DS Slack, which you should sign up for if you haven't already. I'm at Mark there. So that's it. If there's any other questions, I would be happy to take them now. All right. I hope that made sense for people. And I definitely would say it's something where I feel like I've drunk the XState Kool-Aid now. So I will definitely be using it more in the future. Thanks, everybody.
All right. If we don't have more questions, this is a good time to ask them. We'll just carry on with the rest and go to socializing. Okay, not seeing them. Well, let's thank Mark again for presenting. All right. Thanks, Mark.
Yeah, thank you.
Okay, so we don't have any jobs listed right now. If you've got jobs that you want to promote, spam them in the chat, or since there's only about a couple of us, come to the table and promote it there. I don't see anything in the chat. If you want to promote it, go for it. All right. If we're in person, Mark, you want to promote your thing? Oh, be right back. Okay. All right. We want to thank our sponsors. We're kind of low cost right now, but when we get back in person, the sponsors really matter because we typically have some form of catering. So we want to thank Punchcard for their support. We want to thank Jobber for their support. We want to thank Iron Sights for their support, and Startup Edmonton. We're using their Remo account, so that's really nice of them. All right. So if you're interested in sponsoring us, email us at sponsors@exchangejs.com. And hope that we see you at the next meetup. That'll be June 2nd. Okay, so I'm going to return y'all back to the Remo table, and we can chat away.